Thank you very much. My name is Joo-Hong Kim, research scientist at Korea Polar Research Institute. I'd like to show the Earth's upper atmosphere, looking from the space at the North Pole. What you see is the wind speed and direction over there. You can notice the pink and light pink color zone. Here is the surrounding the North Pole. This color denotes very high wind speed, over 150 kilometers per hour, where the center almost reaches the wind speed of 300 kilometers per hour. This zone is called jet stream. The jet stream plays a role in driving the surface weather, so it is very important to understand and predict its behavior. The extreme weather event, climate event includes some wind storm, and then heat and cold wave, and persistent drought, and heavy rain, wildfire that are, which are the menace of the maintenance of the human society. So actually, Venus Reinsurance reported the change in the number of loss events in North America here. This plot clearly shows an increasing trend of them. Closer looking reveals that the increasing trend was mainly attributed to the extreme weather event, and like this. Actually, most of the extreme weather events have a common denominator. Figures shows the schematics related with the different extreme events. You may find a common term in these figures. What is it? It is the blocking. So the blocking means the high pressure area remains nearly stationary. So it is collocated with the region where the jet stream meanders far forward, shaping the omega, the letter. And actually, because blocking is distort the unusual eastward propagating of the weather system, blocking is also called the stock weather pattern. The extreme events are usually related to stock weather events. Thus, the increasing trend of the extreme weather and shown in the previous slide might reflect more frequent and more severe stock weather pattern. So for understanding the stock weather pattern, actually long time ago, the theoretical meteorologist developed a theory of the flow equilibria. This means the atmosphere flow changes by nature between two different states. One is fast flowing regime, and the other is a slow flow regime. Actually, left figure is the fast flow regime with a straight jet stream during this period. The eastward evolution of the weather pattern is generally very efficient. Another feature here is the well-trapped cold air in the Arctic Circle, as shown in the left panel. The polar cold air does not much leak toward the mid-latitude. If they are a well-defined zonal jet. By contrast, in the right side figure shows the slow flow regime with a wavier jet stream. The stock weather pattern is identified here, and the several patches of cold air are displaced toward the mid-latitude, causing the cold surge. Actually, the blocking period is classified as the slow figure regime and the wavy jet stream. So, however, the theory itself cannot explain why there are long-term variability. In the next slide, I present a newly emerging source in the mid-latitude flow pattern, potentially responsible for this kind of variability. It is the Arctic. Here the Arctic is the coldest area in the northern hemisphere. The ice-covered ocean surrounded by permafrost land. The Arctic has an important role in the Earth's climate system. As control of the Earth's temperature by removing the surplus has received in the tropics. Since the second half of the 20th century, here shown the Arctic has been warming almost 3 times faster than the rest of the globe. The figure shows the trend in the surface air temperature shows the largest warming in the Arctic. This is the cold Arctic amplification. The amplified warming in the Arctic is caused by the several positive feedbacks, enhancing the response up to the posing. What is the primary posing? It is of course, anthropogenic posing causing the global warming. So the Arctic amplification is directly related with the Arctic sea ice loss. Since the first satellite-based estimation of the Arctic sea ice cover in 1978, we have been observing the fast shrinking of the Arctic ice cap for all seasons. Particularly, the summer minimum sea ice cover is quickly declining from around 6 to 7 million square kilometer to around 4 million square kilometer in the 2010s. Thus far, I introduced a strong link between increasing extreme weather events and stock weather patterns, and also show the main aspect of Arctic climate change. That is the Arctic amplification and sea ice decline. Although there has been debate whether the Arctic amplification and sea ice loss can cause the anomalous behavior of mid-latitude circulation, many studies show the supportive result based on the observational analysis and numerical modeling. These schematic figures summarize the linkage between the Arctic sea ice loss or Arctic amplification and the wavier jet stream. These are more complicated pictures recently published in scientific journals, actually containing the same conclusion. That is, the Arctic amplification, also known as sea ice loss, is attributed to the wavier jet stream. The upper figures are the mechanism for northern hemisphere winter, and while the lower figure are the mechanism for the northern hemisphere summertime. Okay, let's talk about the future shortly. We can think about the different futures under warmed and ice-rich new Arctic. People think about the positive future, more accessible humans and Arctic sea route, oil and mineral exploration. But we have to think about how expensive the price we may pay for while transporting the new Arctic. If the extremeness of the weather and climate event increases, the price would be very expensive. Actually, in December 2015, the representative of 150 countries around the world consented the Paris Agreement, keeping the global warming within the 1.5 to 2 degrees Celsius. This event was the monumental success for the planet and people, but we still have a long way to go until it comes to effect. In recent couple of years, the global temperature has risen sharply since a decade of persistent weak increasing tendency. We are living near the lower bound of the Paris range. This is my last slide. I conclude my talk with this cartoon. Like this cartoon, we are building up a climate change, the building. The building was founded by science, but still lack of our scientific understanding puts high uncertainty here, making this risky building. For more firm foundation, the scientists should make a tremendous effort for resolving this big issue by true science. This is my end of my talk. Thank you very much. Thank you.